Hi everyone. Today we are going to see about Viterbi decoding algorithm. Normally in communication, the message bits are first encoded from the transmitter side and then it is transmitted and it is received at the receiver. But this is only the ideal case. Practically, what happens during the transmission of the coded sequence, it may be affected by the noise or any other external factors, and at the receiver side, and we receive the code with error. So we need to decode the message, and in addition to this, you need to correct the error also. So we have a powerful tool for this, which is called Viterbi Decoding Algorithm. So before starting the process of decoding algorithm, first we should know some basics of trellis diagram. The detailed explanation of how the message bits are encoded using trellis diagram, it is given in the description below, and you can see it in the pop-up also. Here I'll give a little glance about the trellis diagram. So basically, trellis diagram contains two things. One is the input message bit 0 and the input message bit 1. So these are represented like 0 is represented as a solid line and 1 is represented as dotted line. And in trellis diagram we have two states. One is present state, another one is next state. So we'll start with present state A. So if the present state is in A, and if the message bit is 0, that means solid line, it will move to A itself and it is producing a code of 00. And if the message bit is 1, it is moving towards B and it is producing 11 as code. And similarly, if the present state is B0 and if the message bit is 0 and it is moving towards the next state C and it is producing the code 10, and if it is 1, it will go to D and it is producing 01 as code. In a similar way, from C it is moving to A with a code of 11 and is moving towards B if the input is 1 and it is producing 00 as coded sequence. And from D it is moving to C and again it is moving to D if the input is 1. So this is the basic trellis diagram. Using this logic, we should decode the received sequence at the receiver side. So let's get started with the problem. Decode the received sequence. A sequence is given. We need to decode it using Viterbi algorithm. The first step here is we take the received sequence and write it in pairs. Okay. And then here is the received sequence. We'll start drawing the trellis diagram. So we'll start with A, and we know from A we have two possibilities. The input is 0, that is solid line, it is going to A itself and it is producing 00 as coded output. And if it is 1, it will go to B and code is 11. Next, we should take the received sequence first set, which is 1, 1. And now we are going to compare 1, 1 with these two codes, that is 0, 0 and 1, 1. Right? So let's take the 1, 1. Let's compare 1, 1 with 0, 0. So if you see here in two bit positions, we have difference. So here also we have, instead of 0 we have 1, here also it changes. So what happens? We take the Hamming distance for this code as 2. And if you see second one, which is 1, 1 compared to 1, 1, there is no difference. So the Hamming distance is 0 here. Now we can start with A1 and draw the trellis diagram. So from A1, if the message bit is 0, it is going to A2 and it produces the code 00. From A1, if it is 1, it is going to B2 and produces 11. It goes on. Now again, we'll compare the second set, which is 0, 1 with these four codes. So let's take the first set, which is 0, 1 and 0, 0. Here the difference is in 1 bit position. That means the Hamming distance for this particular set is 1 and we have to add it with the previous Hamming distance. That is 2 plus 1 gives you 3 as metric. Similarly, we'll compare 1, 1 with 0, 1. Here the Hamming distance is 1 and with 1 we will compare this with the previous, which is 2. 2 plus 1 gives you 3. And here the Hamming distance is 2, and this will be added with the previous, will get 2. And here the Hamming distance, there is no difference between 0, 1 and 0, 1. So the Hamming distance for this particular set is 0, and we'll add it with the previous and we'll get 0. Again, we'll continue to draw the trellis diagram by referring to the actual trellis diagram that we have seen previously. And now we'll take the third set, which is 0, 1, and then compare the 0, 1 with each and every codes we have generated. Now let's see the first set, which is 0, 1 and 0, 0. Here the difference here is 1. It will be added with the previous, which is 4. And if you see this particular node, we have two lines entering into this node. So we have to find the Hamming distance for this also. So here 0, 1 compared with 1, 1, we have the Hamming distance as 1, and it will be added with the previous node. The previous node is 2. So 2 plus 1 gives you 3. And similarly, we have to do it for the remaining things. And at this point, we cannot proceed further. The reason is we have two metrics for a single node. So at this point, we have to eliminate the highest metric. So here 4 and 3, the highest metric is 4. It is eliminated, and its path should also be eliminated. And here 4 and 3, the metric and its path gets eliminated. 5 and 0, the maximum metric and its path. And here 3 and 2, here 3 gets eliminated along with its path. Now we have only one metric for every nodes. Now let's continue drawing the trellis diagram. Again, we'll take the fourth set, which is 1, 0. So again, we'll compare with individual codes. 1, 0 with 0, 0, we have the Hamming distance as 1. And we'll compare it with, or we have to add it with 3. So that means we have selected 3 for the next step. So 1 plus 3 gives you 4. And similarly, we have to do it for 1, 1 compared with 1, 0. We'll get Hamming distance 1, and it should be compared, or it should be added with 1 plus 0, which is 1. And for 1, 1 also, here we have 1 Hamming distance. It should be added with 3, and it will be 4. So in similar way, we will do it for the remaining nodes. Now at this point also, we have to eliminate the highest metric. So here 4 and its path gets eliminated. 4 and its path gets eliminated. Here 3 and 4. So this path, the node, gets eliminated. So 5 and 2, here 5 and its path gets eliminated. Now again, continue drawing the trellis diagram. So by referring to the actual trellis diagram, we can draw this diagram. And again, we'll take the last set, which is 0, 1. Now we'll compare and we'll get the metric for each and every node. So at this point, we don't need to cancel the highest metric for each and everything, because we have analyzed all the received sequence. So at the last point, what we should do is just look for the smallest possible metric here. The smallest metric is 1. So this path should be selected. The metric and its corresponding path is selected. Now we are going to draw the survivor path. We'll start from this point. So this is the path that is selected. From this, you travel towards the selected path this way. And here we have two options. One is eliminated. So this is the way and this way, and finally it reaches the first one. So this is the survivor path. So how to write the corrected sequence here? Just look at the survivor path. So here we have 1, 1. So the received sequence is 1, 1. The corrected sequence is 1, 1. There is no error here. So if you see here, the received sequence is 0, 1. Here the selected path is having the code 0, 1. So here also no error. And if you see the next set, here we have 0, 1 and here also we have 0, 1 as code. So no error. And here 1, 0, but here the selected path contains the code 0, 0. So this is the corrected sequence, this is the received sequence, there we have error and it automatically corrects the error. And finally we have 0, 1 and here the path contains 0, 1 as code. Finally we have a received sequence and the error at this point is corrected here by using the trellis diagram. So here's the error and here's the corrected sequence. Now let's decode the actual message that is transmitted at the transmitter side. How we are going to find that? Just look at the survivor path. For this path we have dotted line. We know dotted line means 1. So the decoded message is 1. So here we have dotted line, so 1, and here it is solid line which means 0, 1 and 1. So this is the decoded message that we have obtained from the Viterbi decoding algorithm. I hope you have understood this. Now let's try it by yourself. Decode the sequence using Viterbi algorithm and post your answers in comment box. Thanks for watching.